Okay, alright. Hello everybody, I believe we're live. Let me just check the audio. This is going to be a very quick video, by the way. Hold on. Just a second. Okay. Yeah. Okay, so let's take this down. Let's take this down. Let's take this down. Let's take everything down. Where's my thing? Okay, great. Let's put this over here. Let's get the book. Great. Okay, this is going to be a very quick video. Sorry about the last video. Okay, quick getting into what we're doing. As every intro, although I'll do the intro very quickly, we're going through the Neural Networks from Scratch book. The book is in Python. We're going through it, and I'm translating everything into Golang. Link to the book is in the description. Also, you could go to NNFS. I just do this in every video because I didn't write the book, and the people who wrote it deserve to get credit. So you can buy the book at nnfs.io. You could buy an ebook, hardcover, soft cover, excellent book, highly recommend. In the last video, we talked about activation functions. You could see all the previous videos in the description. There's a link to the playlist. In the last video, we talked about activation functions, and we talked about the activation function that we would be using in our hidden layers called rectified linear. I don't know why we're here. Oh yeah, this is the rectified linear code. The problem is that we were having in the last video, we discussed all the activation functions and what their uses are, and again, I highly recommend you check out that video. That's part 8. This is part 8.5. The problem was he was using a NumPy situation, np.maximum between 0 and inputs in order to get his rectified linear output, and so he had a very easy time making his class. And I was having trouble figuring out exactly how to do it, and I was just having too much trouble in the video. I didn't want to go through like the exploration process in the video too much, although in retrospect maybe I should have. I did a little bit of research. Turns out the answer is pretty simple, and I'm going to go through it today. So let's go back into the code and let's talk about a little bit of what we have. And things might be different from the last video because, well, I've been doing things. So in the main file, we have the first dense layer, which is a shape of 2 by 3, and then we have the first activation, which is going to be a new activation ReLu. And over here, we try to do a forward pass through the first dense using the data x. Again, x is over here in data.go. We have all these data points that we made into tensors to use. Check out a previous video to see exactly how we got all that stuff. But anyway, we're going a forward pass with the x as the input, and then we're trying to do an activation. We're trying to go through the forward of the activation using dense1.output. Okay, so in the machine learning folder that we have over here, we have activations, add biases, which is a function that we had to code, and looking back, I could have done that better, but anyway, it is what it is. And we have our dense layer class. Let's take a look at activations. This is where we're going to be putting all our activation functions. The first one that we have is activation ReLu. So this part is different. Activation ReLu has one attribute. It just has an output, which is a tensor. In the new activation ReLu function, we make a new activation ReLu, and we set the output to be t.new. Now, in the previous video, I had this set to t.new just like this. That threw an error because you always need to have something in the t.new, some option. It's going to have to be like a backing, or it needs to have a shape. But if you only have the shape, you also need to tell it the type. So we don't really know the shape of our output yet, right? We don't really know exactly how it's going to be when we're making our struct. All we really know is that we're working in float 64s. So this would throw an error right now if I just tried to run this code because t.new needs some information. The minimum amount of information we could give it is the type of data that we're putting in, which in this case I'll be saying t.of t.float64. And that's all I need to tell it. Now it knows that the output's going to be of type t.float64. Great. Okay, now in the forward method, what we're going to have to do is actually very similar to what he has over here. The output is equal to the maximum between 0 and inputs. What we could do is we could make use of a built-in function in our tensor library called t.maxBetween. And this takes in two things. It takes in it could take in many things. It could take in as many options as you want, but the two things we're going to be focusing on is the option, the A and the B. These are going to be tensors or denses, denses, which is another type in our tensor library. But basically, it's going to take in two tensors, one of them with certain values, one of them with the other values, and it's basically going to compare all of them at their given locations. And so say you have a tensor, here, let me make this clear, note pad, although I imagine many of you have already figured this out. Say you have a tensor with just one-dimensional shape. You have a tensor 1, 2, 3, 4, and you have another tensor, let's say 3, 2, 1, and I don't know, -5. And you do t.maxBetween, and you pass in this tensor, and this tensor. So the output is going to be the maximum between the two, 3, 2, 3, and 4. And obviously this could be like many dimensional shapes. They just have to have the same shapes, and it will work between the two of them. So you can see how we'll use this for our rectified linear situation. We'll just make the second tensor zeros, right? Right? That's a great idea. Okay, so how are we going to do that? Well, we need to make a tensor with the same shape as our inputs, where all the values are zeros. Okay, so the best way to do that is like this. We'll say zeros colon equals t dot new. And this is going to take in some things. So the first thing we need is the shape, obviously. So t dot with shape. And this is going to be the inputs dot shape, because we want them to have the same shape. So inputs dot shape. Dot dot dot, because shape is a list or a slice, so it needs to dot 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 it to expand it. And then the second option that we're going to be putting in, the only other option we need is the type. So we'll do t dot of float 64. Great, so now that we have the shape and the type, this will automatically initialize all the values to 0, which is exactly what we want. And we can now do max between the two of them. So we'll get output, comma error, colon equals t dot max between the inputs. What is the maximum between the inputs and the zeros? And the reason why we have to do output like this and not go straight into the r.output to set the actual output value is because we also have to handle for the error. So we'll do handle error. And then we can say, and the handle error is a function that we've made previously, which I think is located in dense layer. Yeah, handle error. In fact, there should be one over here as well. No, there isn't. Yeah, it's in dense layer.go. It basically just, if the error is not equal to nil, fatal out with the error. So that will fatal us out. And if we don't fatal out, if we don't exit the program, we'll say r.output equals output. Great, and that is our forward pass through our ReLu. So let's check this and make sure it works. So here we're doing a forward pass through dense1, and now we're going to do a forward pass through activation1 with the dense1.output. And let's fmt.println activation1.output. Great. Let's run this. Okay, and as you can see, oh my god, this is a mess. Oh boy. Yeah, this really does not look good, does it? We have to expand this. Okay, great. So now it looks a little bit better. This is a lot of values. It's only like 300 values, I believe. This is weird. There's like 2 zeros over here. It's probably just like a formatting, like weirdness. So as you can see, there are no values here that are below 0, because that's what ReLu does. If it's above 0, it sets it to whatever value it was, and if it's below 0, it just turns it into 0. And I suppose you could really check this and make sure that there are actually no values above 0, but I'm pretty confident that this is working perfectly. If you want, we could test it. So instead of passing in dense1.output, we could pass in t.new, and then we need to import t, which would be gorgonia.org /tensor. Great. That works, I believe. Figured out. Checking, and it figured. Okay, so got it. Great. And now we could do t.new, t.with backing, and let's just pass in some random values. 1, 2, 3, 4. Although this needs to be a backing, so hold on. Slice of type float 64. Type of okay, and then 1, 2, 3, and let's say -4. And let's 1, 2, 3, 4. Let's say 1, 2, 3, -4, 5, comma, -6. Let's just do it like that. For now, this would be a shape of just, it's going to be like a flat thing. It's going to be a vector. So let's try that, and let's print out the output. Go run that. So 1, 2, 3, 0, 5, 0. So that's working. Now let's see if we can mess with the shape a little bit, just to make sure that it's keeping its shape. So yeah, we come over here, we do t.with shape. Let's say, well, how many is this? 1, 2, 3, 4, 5, 6. So let's say 2 comma 3. I'll have a shape of 2, comma 3. Let's try that. Okay, very good. So this is working as well. It's keeping the shape, and now let's try to make it like a three-dimensional shape. So how would we do that? 1, 2, 1, 2, 1, 2, 1, 2. No, that's still two-dimensional. Three-dimensional is hard to think about. Oh, it's annoying. Maybe if we get 9 values. Here, let's come over here. Three-dimensional is hard to think about. I just need this to look at it. So I'll come over here and we'll say like this and like this, like that. So that's two-dimensional, right? Everything here is two-dimensional. And now we want to add a third dimension. So how would we do that? Well, we could say we would have to add some new values, I guess. I don't know. What does three-dimensional even mean? It means that there's a list, and then each one of those has a list of lists. So let's come over here, and next to each 2 of these, we're going to add another value. So let's do a 2 over here, and let's do a -4 over here, or something. Let's come over here. We could do like -10 over here, and over here we'll put like, I don't know, 8. And over here we can say, let's say -16 and -82. I don't know. Okay, so this could be organized into a shape of, let's say, 3, comma 2, comma 2, right? Yeah, this could be organized into a shape of 3, comma 2, comma 2, I believe. If it can't, then that'll be a separate thing. So let's put in backing over here. All right, let's try this out. Nope, okay, clearly I messed something up. Shape mismatch expected 3, comma 2, comma 2 got 10. Where did this happen? I hope it happened in our thing. Yeah, no. Yeah, okay, so I messed up the shape. 1, 2, 3. And then there'll be 2 values for each of them. Ah, here. Yeah, I forgot a comma over there. As well as over here. So that's probably messing it up. So it thinks I'm doing like arithmetic. I'm not doing arithmetic. Let's try that again. Okay, great. So as you can see, yeah, this is going to be a shape of 3, comma 2, and each one of them has 2 values. And it's getting rid of all the negative numbers, which is great. So this is working, which is excellent. We have our ReLu. So let's change this back to dense1.output. And again, we'll run it again, just to make sure. Great. So this is working, and again, for our activations, it's as simple as making a tensor with the same shape, but all zeros, and then comparing the 2 of them to get the output, handling the error, and then if the error is not null, setting the final output of our ReLu activation struct to be that output. So that was the entire video. Hope you enjoyed. That is it for today. Or not today, like that is it for now. Just wanted to make this part, like 8.5 part, so that everything works and we know exactly what we're doing. I'm going to end the stream, and in the next video we will start talking about the softmax activation function and why it's useful and why we will be using it. So until that time, have a great day, and I'm going to end the stream now. Goodbye.